Okay, welcome to everybody joining online. Welcome especially if you are a participant of one of the meetups I've been doing in the last week and a half. If you are, as usual, please use our standard Twitter channel, Euclid_project, to give us a shout. That would be an edit point for the recorded webinar, and I'll try not to be so tongue-twisted for the next 2 hours. Okay, welcome to Euclid's Module 3 webinar, whether you're watching it live or whether you're watching it recorded on Vimeo. Particularly excited about this module where we'll be talking about providing linked data. So how to take it from different sources and how to publish it. So as part of our motivating scenario, this particular module fits in more or less in interlinking and cleansing, in publishing RDFA, providing a SPARQL endpoint, and in transforming non-linked data sources into linked data. So there's a lot to cover, but it's interesting stuff. In order to provide some sort of structure of all of these tasks, many people in the area have come up with what are called linked data life cycles. So to some level of granularity, the tasks that are involved in doing all of these things and how they relate together. All of them essentially are guiding you through these 4 overarching principles that define linked data. So to review, calling everything, our things as well as our documents become resources, and resources are given uniform resource identifiers, URIs. In particular, the second principle says we use HTTP URIs in order that we can look those things up to understand them. The third principle says when you look up, use the standards that have been defined in the semantic web space to give the understanding. So use RDF star, which means RDF in XML, RDF in attributes, which is RDFA, which we'll talk a bit more about this time, and Turtle, and at least as an upcoming standard, which we've used throughout, also provides SPARQL where feasible and where useful. The fourth principle is about interlinking things to allow people to discover, often beyond your data set, by linking to things in other data sets. So we'll talk about both the techniques and the tools to cover these principles within the scope of life cycles like this one. So the LOD2 project has this nice continually circular approach to life cycle, where we could start at some point, for instance, by looking at the interlinking of our data with other people's, and then enrich that data, including enhancing classification, so people can look up resources from our data and from other people's according to agreed classifications, classes in vocabularies. It talks about how to perform quality analysis, particularly important when either you're producing for the first time data from other sources and or when you're interlinking to somewhat unknown third-party sources. You want to know how high quality the data is, how well it's represented, how well metadata is available for resources, etc. Inevitably, we go into evolution and repair as 2 sides of that. So either how do you put things right if they're wrong, or how do you evolve them towards a higher degree of interlinkage. We enable, which is kind of ourselves and now other people, external parties, search, browsing, and exploration, something that the next Euclid module, Module 4, will have a lot to tell us about. We might do some extraction, which the second half of this webinar has plenty to say about. We've talked to some degree already in Module 2 about providing storage and querying. And then the life cycle often involves some manual processes. So actually going down and either curating data that's out there or authoring new data. So we might bootstrap through these kind of processes, but then ultimately allow people to produce more data by interaction with the system that we build. Simpler view on life cycle provided down here. We produce, we publish, other people consume, and we integrate feedback and make updates, all of which centrally has some validation mechanism. Alternatively, more of a waterfall view, starting from awareness of data that's out there, something that we'll talk about, how you find data that already exists, through modeling, where we have to build new vocabulary, publishing. They focus here on discovery, which is quite important. Again, we'll have more to say about that. Integration of further data, and provision of use cases to show how it can be used. So within our use case, which is building a music portal, we concretize this stuff down, abstract it into 3 tasks: curation, interlinking, and publishing. And you can see on this slide our rough map of which of the overarching linked data principles are primarily associated with each one of these things. So we talk about principles 1 and 2 for creating, whether that be by hand creation or by extraction from a non-linked data source. Principle 4 is all about interlinking, and we'll show the tools that can be used to support that. Principle 3 is really about publishing. What do you give people back when they ask for the things identified by your URIs? So that gives us an agenda for this first part of the webinar. We'll talk about creating, interlinking, and publishing, and then give a checklist, okay? Something to judge yourself against, see how well are you doing with producing and publishing linked data. So starting with creation, in the second part of the webinar, we'll have more to say about the tools that you can use, and we'll give you an idea of what the interaction with those tools are, what the capabilities are, and put into the context of our music application what kind of results one might expect from that. So we'll cover extraction of data from tabular data, especially spreadsheets, with what used to be called Freebase Refine, then Google Refine, now is called Open Refine. We'll talk about creation of linked data from structured relational database sources. So in particular, we'll talk about this new standard from the W3C called relational to RDF mapping. And then we'll talk about creation of data from free structured text, from human readable texts. So we'll look at some of the generic solutions like DBpedia Spotlight and Samantha, and then we'll show how custom text platforms that are aware of linked data, like Gate, can be useful in producing linked data. Okay, so the diagram that will always come up in Euclid, always come up in semantics in general, reminds us that everything that we do, all of the vocabularies that we make, the rich data that we make, the interlinkage that we make with other data sets, all comes down to triples, comes down to arcs in a graph in a data model. So just to recall, because it will come up today as much as ever, the triples in RDF, these statements made of 3 parts, consist of a subject, a predicate, and an object. The subject and objects are 2 resources in a relationship, and the predicate tells us which relationship holds between them. Okay, with that in mind, let's look at the naming part of linked data principles. So all of the things we say that we share an idea of with people should be identified. Unlike the web of documents, which is most of the current web, we're not just interested in identifying documents with URLs, but we'll identify, for instance, this webinar, myself, its audience. They're all things, non-document things. They equally get URIs. And the relationships that we share by you're watching this webinar can be modeled in RDF through those URIs that we're given. Now, again, something we trace back to Tim Berners-Lee's idea for how these technologies should work together is the idea of cool URIs. Among the properties that makes cool URIs cool are simplicity, so not overcomplicating, certainly lengthwise, the identifiers that are given in URIs. Stability, absolutely critical. Don't go changing, don't go disappearing. And also some manageability issues that are well described in this W3C note. When it comes to vocabularies, you hear people in this community talk almost interchangeably about schemas and ontologies and vocabularies, and that's quite proper. A vocabulary defines two things for you, two things alone. Classes, that is a model of the kind of resources you talk about using the vocabulary, and properties that describe the relationships that are expected to hold between them, the relationships that are modeled. A vocabulary is purely about telling you which classes and which properties are being described and how you can relate the properties and the classes together. Okay? On a simplest level, to tell you this property holds between two particular classes. In a more deeply reasoning world, to take your resources and look at the relationships and classes that they have and infer further relationships and classifications. Okay. When we publish data in linked data form, we strive as far as possible to use existing vocabularies. Okay? So if people have already told us using the classes in their vocabularies, be they schemas, be they ontologies, where the classes represent the things that we want to talk about, we want to reuse their vocabulary, reuse the classes and reuse the properties by which they've already modeled relationships. In fact, we should only define new classes and properties where they don't exist in some existing vocabularies. Now, if we want to, then, therefore the question comes up, well, how do we find them? One forward reference here is to a project called Linked Open Vocabularies. So it's a survey of those vocabularies that are used in the enormous amount of linked open data that's available already on the web. Linked Open Vocabularies has some nice structure, and that structure is represented in very nice visualizations. For instance, this bubble diagram. So one way to navigate this collection of vocabularies is top-down, popping bubbles, if you like, to find your way into this data set of vocabularies. So we could look at a particular domain, go into that bubble, and then look at some aspect of it and go into another bubble until we get down to a concrete vocabulary that we want to use. Okay? When we use it, it doesn't mean that we commit wholesale to all of the properties in that vocabulary. We might just be interested in a few and the classes that they're tied to. Linked Open Vocabularies also in surveying and collecting this use of vocabularies provide some more nice visualizations within the vocabulary to tell us how it's made up. So here, this analysis of the music ontology, which we've used in the module so far and will use more in this webinar and later, it looks at the music ontology and it considers the other vocabularies that the music ontology uses. Okay? So just as the recommendation to you is, if you're publishing data in slightly distinctive new area, that you should look what vocabularies should you reuse, and if there's anything missing, you create new vocabulary terms. So the music ontology doesn't start from ground up and try to model everything in music. Instead, it says many of the things that are involved in music already exist, and we should point to the use of those vocabularies for parts that are already covered, and then build our specific classes and properties over the top of that. So you can see over on the right-hand side, right up at the top, that one of the big uses of vocabulary in the context of music ontology is FOF. Okay? FOF describes people and gives them names and relationships. Well, in the music domain, there are lots of people, music artists, and indeed they have names and to some degree relate to one another. So we make use of FOF in describing music. To point out another vocabulary which is a recurrent theme through the Euclid modules, over here, as one of the next nearest blocks, we have the Dublin Core. Okay? The Dublin Core gives generic metadata to works. Well, the music domain has lots of works, musical works. So we reuse the Dublin Core to give, for instance, titles and provenance in terms of publication at a point in time to artifacts modeled otherwise using the music ontology. So 2 more places where we can go to find vocabularies when we want to model our data. The Semantic Web Education and Outreach group at the W3C called Linking Open Data provides a list of common vocabularies that you would probably want to look through. Okay? They do it in a generic way, regardless of domain. Some specific domains have enough traction already with linked data that they'll collect a list of vocabularies and best practice relevant to that specific domain. So for instance, if you're looking at linked data for libraries, you could go to the linked library data incubation group and there find their vocabulary list. Okay, now a word about interlinking. So if we've chosen our vocabulary, we know our data, where we're going to get our data from. The last thing that we have to do in order to fulfill these principles for linked data is interlink with other things. So that could be, and primarily perhaps is, at the instance level. When I say I have such a resource, it could be that I didn't know, or I'm deliberately keeping my mind separate from a resource that you already have in another data set. Okay? Could also be that I'm consuming 2 existing data sets and they overlap one another by giving different names to the same thing. So our running example later is going to be the Beatles. The Beatles are identified in MusicBrainz. They're also identified in DBpedia and elsewhere. Okay? So part of our interlinking might be to say our resource is the same as that resource. Now when we come to give some more details on this later, we'll see same as is not always the best choice because we're not always talking about a perfect match. So sometimes we might use other vocabulary to give an idea that things are aligned but not necessarily quite identified. So we might use see also from RDFS. We'll see shortly, we might use SCOS vocabulary. An alignment that we also might want to do is at the schema level. Okay? So if we've produced some vocabulary, or even in some cases reused vocabulary, which is non-exclusive, which overlaps with another vocabulary, we might want to make the alignments at the schema level. Say this class is the same as that one. This property describes the same relationship as that property in another vocabulary. So we might want to use OWL vocabulary to do that as an exact thing with inference, or again, we might want to use SCOS to point people in that direction, but without inferring absolute identification. These kind of links are acquiring them by tooling can be described as link discovery, and we'll have a look later at one tool that's oriented around doing link discovery at the instance level. Okay? 1, because that's prevalent. 2, because it's a very large problem often when you encounter it. The number of music artists that exist both in DBpedia and in MusicBrainz is far too large for someone to do that by manual creation of links. Okay? We might be able to look at the 2 ontologies and make the schema level alignment, but when it comes down to the number of instances, there's so many tens of thousands of things that are the same that we need some link discovery semi-automated tool support. So the challenges for that, well, the linked data sets are heterogeneous. They'll not just talk about the same resources, they'll probably talk about them in different vocabularies from one another. There might also be issues more easily surmountable by tools like format and representational differences. There's a lot of domains to consider, and links between or within each of them have such large quantities of data that we need, as I said, some scalable solution to helping us make those identifications. Another word you might have heard for the issue is entity resolution, okay? And there's two kinds of areas that the tools will look at and help us overcome this resolution or identification. One is in imperfect data, especially with human-oriented naming, there might be misspellings and typos and variants when it comes to labeling. Okay? Labeling is at once perhaps the most promising way to identify things, but also the most error-prone, given the way that, as one example, human names are represented is highly variant. Do we have surname, comma, forename? Do we include a middle name? Do we include an initial? What do we do with hyphenated names, etc.? At the same time, there's a structural aspect to this. If the data sets really overlap, not just in naming things, in identifying things with names, but also in giving relationships to those things, we can also look at the relationship, look at the graph to try to do resolution, which is why at the instance level, we share things in common with aligning things at the vocabulary level when we try to align classes and properties. So, as I've said, the interlinkage may be something that to some degree we can do manually, to manually explore things and look for, especially at the vocabulary level where things are smaller, properties that seem to be in common, that seem to be describing a similar relationship. On the other hand, however, beyond a certain scale, we really need some automatic help to do this. So there are tools like Silk, Limes, and Xcurator that can help in this task, and in the second half of the webinar we'll describe Silk as exactly one of those means of semi-automated support. Just to reiterate this instance identification difference, when we use OWL same as, and this is something that we introduced with regard to inference in Module 2, if you link two individuals with OWL same as, it really says that these are just two different URIs for the same thing. Therefore, anything that can be recovered from assertions or from inference on one is available attached to the other URI because it's the same resource, and vice versa. So we're really talking about a merge of everything that's known about these two previously separate things. Okay? Other predicates like see also don't do that at all. They just say there's some link between these two things that might be worth exploring, but there's no inference, there's no merge of information. With regard to our motivating scenario, both of these things are used. Okay? So where, as I said, the Beatles are identified in MusicBrainz and they're also identified in DBpedia, the identification is strong enough that we will really use OWL same as to share all of the metadata from both of these data sets and anything else that aligns with same as with those things. And remember that many things do with DBpedia, and sleep comfortably at night. On the other hand, if we try to identify all of the albums in MusicBrainz with pages on Wikipedia leading to DBpedia IDs that represent those albums, we would start to lose sleep because we'd start to over-identify things. So in particular examples, separate entities in MusicBrainz would become the same as one another because they would both be the same as something that's not so well defined in Wikipedia. Okay? So Wikipedia in general has an issue. It's often not clear what exactly the page is about. MusicBrainz makes fine distinctions between the event of a recording session where Sgt. Pepper's was first laid down in the studio from release groups, including release events in different countries of the world on different media of that album, okay? And grows even more complex where, especially in the Beatles catalogue, We separate release groups for the original mono release, for a stereo version of that, for the 24-bit stereo remastering. All of these are different signals leading to different releases that we don't want to identify and lose this distinction just because the Wikipedia page talks in some vague terms about Sgt. Pepper's. So, another vocabulary that we will use in alignment and elsewhere is called SCOS, or, having been in the United States talking about it for a week, SCOS. Okay? However it's pronounced, what it stands for is the Simple Knowledge Organization System. It's, in some ways, if you stick to using SCOS by itself, strips out a lot of the complexity of ontology design and brings us back to the world of taxonomy design. Okay? So we have hierarchies without instances, and then we start making annotations into that hierarchy and alignments between hierarchies. Okay? And it's these alignments, the vocabulary for that we might want to use more generally. So here are three of the predicates that might be interesting to us from SCOS to carry out this alignment. One is called close match, that says they're sufficiently similar that in some situations they can be used interchangeably. Okay? So unlike owl same as, we're not saying they are indistinguishable, and if you use one, you are using the other one. Okay? So they're de facto substitutable. Instead, it's just guidance that you might be able to substitute one for another in context. Okay? Getting even finer, we can use exact match from SCOS that again says there's interchangeability, but it's absolute this time. It's not qualified to say sometimes you can use one for another. All the same, it doesn't do the inference that same as does to say all the same things apply and you can query for either one in the place of another. Okay? But it does get closer to being an equality in that, for instance, it's transitive. This time, really, if you say A is an exact match for B and B is an exact match for C, well, therefore, A must be an exact match for C. Okay? We can also, in SCOS, less relevant to the alignment that we're doing, but just for information, specify a related match between two concepts, which is associative. So here's an exact match we might want to carry out. Okay? We have the ontology for music, the music ontology in other words, and we have the ontology for DBpedia. And they define classes which are more or less interchangeable. If we didn't, as we've seen the ability in the previous module to do in OWL, say, we want to impose this and get all of the inference. That means those classes have one another's members, but we did want to indicate that there's some exchangeability here. We might use SCOS, even outside the SCOS world, to say there's an exact match between the class music artist in music ontology and musical artist in DBpedia. Similarly, music ontology's music group and DBpedia's band. And we also might make this alignment between music ontology's music group and music group from schema.org. Okay? So increasingly you'll find that alignment between DBpedia and schema.org is actually coming along with the use of DBpedia, which is quite useful. We'll say more about schema.org later. As close match, we might want to say, so exactly as I've said, at the instance level, we might be comfortable with aligning Music Brain's artist, modeled in the music ontology, with DBpedia's artists, but would not be comfortable with modelling signal groups, the real idea of an album as recorded in the studio in Music Brain's through music ontology, with DBpedia's albums. Okay? So we're certainly not going to say this is an exact match, but we could say that it's a close match. It's really true that in 95% plus of the occurrences of potential pairings here, that it is going to be a proper match. It's mostly edge cases that say sometimes Wikipedia conflates things together that it shouldn't. So recording that there's a close match there might be interesting, either at the schema.org level or at the DBpedia level. Okay, now SCOS comes along with some integrity conditions when we use these kind of maps. In particular, it says related, which is why it mentioned, must be disjoint with exact match. Okay, two things can't be in both of those relationships at the same time. We have that exact match. I mentioned transitivity already, but also like any equality, mathematically speaking, it's symmetric. So everything must be an exact match for itself, and anything for which you are an exact match, you're also an exact match to its exact matches. Close match, on the other hand, is only symmetric. Okay? If I'm close to this, and it's close to something else, and it's kind of close to something else, kind of close to something else, we don't jump across this train and therefore say, there still must be some similarity that holds here. Rather like Chinese whispers, if we lose a little bit each time, we don't make any statement about what happens across a long chain. So, without further ado, we move on to how to publish this stuff, guidelines for publishing this stuff with respect to best practice. So, what we're asked to do in publishing our data usefully is to create metadata describing the data set. So we reflect on the data to get other people an abstract view in metadata or data about the data. There's best practice for making it accessible, giving people access to it. Okay? There are repositories for telling people what the metadata is and where and how the data is available. And there's an amount of validation that we should do in the wild. So, in order to describe our data sets, give them their own metadata, what we're looking for is the ability to give efficient and effective searches over data sets. So if someone has a data need, they're going to be able to find our data set and know that it's potentially useful. We're going to help them select and consume our data and also give them statistics about our data. Okay? So it might be the perfect fit for their data need in terms of what's modeled, but no good as a fit if it's too sparse, if there's too little of it, okay? Or vice versa. But in combination, these three things, what's there, how do I get it, and how much of it is there, I can make a judgment of whether that data set is going to fit my data need. The most common vocabulary to attach the metadata to a data set is the vocabulary named void, vocabulary of interlinked data sets. Okay? Its primary class, its primary kind of resource that it talks about is, of course, data set. Okay? So instances of data set are given metadata, and that metadata fits into four broad types. We have general stuff, the catch-all. We have the structural things, so what it means interpreted as a graph. We have description of link sets, okay? Because one of our four principles is how well is it linked with other things. We can really describe its link sets, those set of statements that are about interlinking. And then we have the access metadata. How do you get it? How do you use it? So the general metadata is the top level for helping users find, helping users discover your data set. Not important is just what kind of thing's in there, but also is it useful to you, as in, for instance, being allowed to use it. It's no good publishing data unless you attach a license to it. This is where you attach the license to tell people how they are allowed to use it. Okay? It's also important to give contact people and maintainers contact information. Okay? So if we've questions about this data set, we know where to go. In order to give this general metadata, what's it called, when was it produced, who created it, who contributed to it, and what are those people's details, just like any good vocabulary, Void will reuse Dublin Core and FOAF, just as we were earlier describing that music ontology does. These are in particular some of the properties that are picked from those vocabularies to describe data sets using Void. So we'll use Dublin Core to give a title and description to it, a source and a creator, date that it was created. Sorry, I'm just trying to remember the difference between date created and issued. Yeah, you can create something and not put it immediately online, so you issue it later. Yeah, I guess. I've never made that distinction, but there we go. Certainly modification date, if you make changes and republish them. And then we use FOAF in combination with DC to give that information about contacting people. So as well as the creator, there might be a home page, there might be a publisher, and a contributor. Okay, so as I said, license is an important one there, and Dublin Core will let us point at a license, just like, for instance, the Euclid material is made available under Creative Commons with attribution license. We can categorize the data set using subject to point at the subject area that's covered in the data. And then we can document technical features, such as, for instance, what serialization of RDF our data set's available in, if it's available as a dump. The structural metadata looks at the data as a graph and looks at internal properties there to help people from the outside understand, through this abstract metadata view, what's in there. So one way to find your way into a data set is to use this structural metadata as a guide to querying over the data to explore. Okay? So you can view them as the starting points for queries that will let you dig in further. This structural stuff includes information about resources, the vocabularies used, and statistics over that. So how well populated are different parts of the used vocabularies. It will give specific example resources. So again, if you know an example resource, you have a hook to start querying. If you know the vocabulary that's used, and in particular which classes or properties from that vocabulary are well populated, you've got a hook to start making queries to dig into that data and find out what's there. So for example, if we model music brains as a data set using this Void vocabulary, we might point at an example resource, which I believe is the Beatles. Okay? We might also say, use the URI space to say all of the resources that you get that belong to this data set fit under a certain URL, a URI space. The property Void vocabulary lets us point at vocabularies that are used in encoding the classifications and the relationships in the data set. Usually, we use Void vocabulary to point only at the primary vocabularies that are used, not the ones that are occasionally but kind of non-significantly used. So the most interesting thing that one could tell someone about our encoding of the music brains data set is that its vocabulary is the music ontology. Statistic-wise, there's a number of properties here that we might want to apply either to the whole data set or to subsets of it, as we'll see shortly. Okay? So we could count the overall number of triples, we could count the entities that are related together in those triples, We could count the number of classes, count the number of properties, count the number of resources which provide distinct subjects to triples. Okay? So you might have used one resource 6 times, one resource 4 times, but if those are the only as subjects, but if those are the only subjects, then the distinct subject count is 2. Okay? We do the same thing with distinct objects, and we might also, depending on how we publish our data, usefully tell people how many documents there are. Okay? So is each resource resolvable as a document, or are they included in larger documents, especially with hash URIs? So are there fewer documents than resources? Or in some sense, if we really don't fulfill the best practice and make things resolvable, is there just one or a few big documents that have all of our data in? Okay, now, as I said, we can model not just the whole data set, but subsets of it. So we could decide that an interesting thing to do is to say, not only is MusicBrainz as a whole a data set, but it's got a subset called MusicBrainz artists, okay, and then attach statistics at that level instead of to the whole data set. Another way to cut up the data set that we're providing is to make a partition based on the use of classes or based on the use of particular properties. So we could make a class partition, so-called, that relies on the class release. So we pull together all the releases in the MusicBrainz dataset according to the music ontology. Similarly, we could say we pull together a partition which is just about band membership using the member property from music ontology. A particular subset of our dataset that's reusable even without our data is the link set. Okay? The link set is wholly about alignment between our resources and other people's resources. Okay? So we could say we have 2 data sets, for instance, MusicBrainz and DBpedia, that the MusicBrainz part, the first data set, has a subset, LS1, which is a link set. Okay? So that link set, link predicate, which predicate it uses to make the alignments, to make the pairings, is our same as. Okay? And because all we've said is that LS1 is a subset of DS1, we also need to say that its target includes DS2, so we know what it's mapping onto using our same as pairings. So here's a longer example pulled together. MusicBrainz is a data set, DBpedia is a data set. MusicBrainz has a partition of the MusicBrainz artists, which is based on the class music artist from the music ontology. Music artists is actually a link set. Its link predicate is SCOS exact match in this case, and the target is between MusicBrainz and DBpedia. Okay, another part, as just stated, of Void is the access metadata. Where do we get this stuff from, and can we interact with it? Okay. The interaction, the most important part, the third principle in linked data, is if you've got the URI for something, you should be able to look it up. The seamless way that ought always to work is just by using the URI itself. Okay? Essentially, you have some redirection. You need to go to an endpoint to look up your URI. For instance, sometimes Freebase works this way. So you might want to point to a lookup endpoint, which is different from just looking directly up your URI. Some data sets have an interesting notion of a root resource. If I had a data set describing me and all aspects of my life, if I were a life blogger, then I might want to say that I'm the root resource for it. If a university publishes all of its timetable and building information, it might want to say that the resource for the university itself is the root resource. Okay? So optionally, it might be worth pointing at one resource as the one that everything else follows from. Many, but not all, data sets will provide a SPARQL endpoint. Okay? So having been talking about music brains, we are in Euclid giving a SPARQL endpoint for the music brains data that we're talking about. But many projects might say it's too expensive to provide publicly accessible SPARQL, so we don't do that. So again, this is quite optional. In lieu of providing a SPARQL endpoint, or in general to help people make efficient and reliable solutions, what one often does is to snapshot data if it changes, okay, or convert it once and for all if it doesn't change, and give people access to a dump of that data. Okay? So most often we'll pick a format that's easy to chop up and distribute, like n triples or n quads, and compress them into a big archive and give a download link. Okay? So this is what DBpedia does and Freebase does, and what we do with Music Brains in addition to the SPARQL endpoint. Okay, when it comes to access, we have these different means to do it. Dereferencing over HTTP, making queries to a SPARQL endpoint, or grabbing a dump, which we might use to reconstitute that data in a triple store with the SPARQL interface. One means that we haven't said so much about so far is RDFA. Okay? In RDFA, we resolve to XHTML, or in general, XML documents, and the RDF rides along for free. Okay? It's RDF in attributes. So for instance, every time you go to a musicbrains.org page, say for the Beatles, you retrieve an HTML page, but the RDF is there in the attributes of the HTML document. So you can distill out all of the RDF content. One question just to revisit: if we resolve resources individually, so if we resolve the Beatles and then we resolve Sgt. Pepper's, these are resources that stand in relation to one another, but when we resolve one of their identifiers, we're interested in a description of that resource. So we might ask ourselves, well, what actually should we return? Okay. Checklist here of possibilities. We could just give back triples, so RDF relationships, where the thing that was asked about, the thing with the URI that was asked about, is the subject. So you could call those immediate descriptive relations. On the other hand, we might like what you could call backlinks, what the paper quoted did call backlinks, which is those relationships where the thing that you asked about is the object. Okay, so who's related to this thing? Okay, there are other related descriptions we might be able to find. Okay, if you've asked about this, it might be useful to know this associated stuff as well. We might also want to include metadata in the sense of provenance metadata. Okay, I'm giving you this data about the Beatles, but I'm also giving you license to reuse that. And if I'm asking for attribution, I'm telling you who created that data in order that they can be attributed. Okay? And then finally, somewhat out of date, because the discussion moves on, still relevant question, what syntax should you provide? Standardization so far has answered first RDF and XML, and then RDFA as a standardized alternative. The community pressure is very much towards giving Turtle. Okay? But none of them are absolute choices. A good citizen will use HTTP content negotiation, because we're talking about an HTTP request, to provide anything that's asked for. You know? My happiest, the source with which I'm happiest will give me HTML that has RDFA in attributes, so I can first have a look at that page. Or if I want to deal with a machine who expects RDF in XML, give it to me so I can pipe it, or give me turtle if I want to read it, just based on my request. Okay, so actually DBpedia these days does that. If you ask for a resource described by DBpedia, it used to be that you would get redirected to a page that was pure HTML, or if you asked for RDF, it would give you RDF in XML, or if you used the right media type, it used to be slightly broken, it would give you turtle. These days, even if it does the default thing, so even if you don't ask and it gives you HTML, there's RDFA there. So what is this RDFA, RDF in attributes thing? The 5-minute guide before we take a break. It's an extension to originally XHTML with some compatibility with HTML5 that embeds RDF within an HTML document. So in some sense, it bridges this idea of the web of documents and the web of data. It's a complete serialization of RDF. So anything that you can say in an RDF in XML document or in a turtle document, you can say in RDFA in a web page. Okay? The simplest way to show that is just to do a simple syntactic transformation. So just as we turn RDF and XML into turtle, we can turn either of them into a block of RDFA, which is just self-contained. Okay? And carry that in an HTML page wrapper. Okay? A more useful way to use it is really to use the extent of HTML features that we embed our RDF into to span text in the human viewable page to make them as annotations to that text. So really where we say on the page, the Beatles, we put our tags around that, okay, so that the Beatles is displayed to the human reader, but this bit of text, the Beatles, is stripped out as the literal value to an RDF assertion about the resource. In order to do that, we have these attributes. We can specify namespace prefixes just like we're used to doing at the start of Turtle. We can specify the actual vocabularies that we're using. In order to embed a statement where the subject is already represented in the HTML, or in general as XHTML and XML, we use the about attribute to specify where the subject is. Okay? We can use especially property to express what the semantic relationship is, and to some degree in full RDFA we might use rel and even rev to do similar. Using hrefs, building on the way that hrefs are used in HTML, we can specify objects to relationships. So if you're pointing out from the document somewhere else with an href, we can say, well, actually, you're representing a relationship, and that's the object of the relationship. If you're not, we can use resource to specify the object ourselves in the RDFA. And just skipping on slightly, we can also attach tagging information, language and data type tags, just as in the RDF that we've seen so far. Perhaps quite importantly, we can use type of to give a class to things in the RDF sense. So if we have a look at a quick example of a few of those put together in a musicbrains.org page here, it's a page about an artist. Again, I'm going to presume the Beatles. And we say about with a URI, okay, the URI for the Beatles, okay, not for the Beatles document, for the Beatles themselves, because that's distinguished by having a #_, essentially what this document is about, not the document itself, the Beatles, and we use this type of attribute and give that attribute a value of music group in the music ontology. Okay? So if we run a distiller over this HTML page, or let's go the other way. If we run a browser over this HTML page, we haven't interfered with the HTML. We've just added some attributes that the browser doesn't care about for physical layout. On the other hand, if we run a tool called a distiller over this page, then we can pull out this RDF triple from these two attributes. So the Beatles are a music group. Okay, so there is the page for the Beatles. There is a distiller. Okay, so you can go to this URI and put in the document for the Beatles, and it will pull out everything that's in there. Okay, so there's many, many triples about the Beatles in that musicbrains.org page. And you can watch the screencast that's already available from Euclid at Vimeo at the URL given. Okay, a dump is some serialization of RDF, as I said, normally compressed in an archive format. So what you find is that these serializations used for any serious amount of data are seriously repetitive. Okay? So, for instance, in MusicBrainz, we go down from an unexpanded serialization in N triples that's tens of gigabytes down to just a couple of gigabytes and make that available. If you want to find all of the dumps that you can download and build yourself very quickly a huge triple store, the W3C does maintain some list of those. With regard to the Sparkle endpoint, the pointer is back to Chapter 2 to see how to do that. Linked data catalogues are tools that are used to advertise data sets. So we can register our data sets and say where all of these things are. Give all of the information to create the void and tell it where are our endpoints, where are our Sparkle endpoints, where are our dumps, and register that for other people to see. Okay? So the second half of this webinar, after a short break, is concerned with that tooling to help us with that process. So we'll start with a discussion of these linked data catalogues and then talk about the tools that can be used to help us produce some of the linked data. Okay? So the session would start again at 3:15. That's 3:15 on British Summer Time. If you have any questions during the break, as usual, please go to our Euclid channel. Thank you.